Now before we've been doing effective resistance of resistors in series alone, then we find the effective resistance of resistors in parallel alone. Now we're going to look at an example where we are having a circuit where we are having both a combination of series and parallel resistors in one. So how do we find the effective resistance of this kind of combination? So the questions are set in such a way that we are able to do this step by step. We are going to first find the effective resistance of the resistors in parallel in this. Then we shall find the total resistance of the resistors in the whole circuit. Then afterwards we will find the total current flowing in the circuit. Then we'll be able to find the total current flowing through the 3 ohm resistor. In some cases they will just tell you that find the current flowing through the 3 ohm resistors, or they'll just tell you to find the total current flowing through the circuit. They just give you this. And so when they give you that question, automatically you must carry out these other steps before you come to this. So we'll begin with this, going step by step. Roman 1, what is the effective resistance of the resistors in parallel? Now the resistors in parallel we have here, this is our dry cell, and when you look at our dry cell, current is going to move in out from here, from the positive terminal, because the conventional direction of current is that current moves from positive to negative. So it will move and it will go through that 1 ohm resistor. When this current comes here, it's going to be split. Some current will go right there, some will come this way, and current will go through there. Then it will recombine at that junction, then it will go back to the cell. What does that mean? It means that the amount of current going through this 1 ohm resistor is the same amount of current that is going through this combination of resistors, because when it just comes in here, it just splits, but it is the same current going in through this combination. So it simply means that this 1 ohm resistor and this combination are in series, and then since these two are getting current that is being split at this point, it means this resistor and that resistor are in parallel. So to find the effective resistance of the resistors in parallel, these are the resistors in parallel. So we'll go ahead and find their effective resistance. To answer Roman 1, the effective resistance of the resistors in parallel, since they're in parallel, we know that 1 over R, and they are 2 resistors, so 1 over R is going to be equal to 1 over R1 plus 1 over R2. So the effective resistance R1 over R is going to be equal to 1 over R1, since they are both 3 ohms, so it's going to be a third, plus 1 over R2 is also a third, 3 ohms, so it's a third plus a third. So we shall end up with 1 over R giving you 2 over 3. When we make R the subject of the formula, we shall end up with our value of R as 3 over 2 ohms. So the effective resistance there is 3 over 2 ohms. That's the effective resistance of the resistors in parallel. So now, after finding the effective resistors of the resistors in parallel, it means that our circuit diagram is going to change. For us to be able to find the total resistance in the circuit, when we got the effective resistance of the resistors in parallel here, our circuit diagram will change, and this is how it's going to change. Now in our previous questions, we were able to find the effective resistance of this parallel combination. Since we found the effective resistance of this parallel combination to be 3 over 2 ohms, it simply means that what was previously here has now become one big resistor, which is 3 over 2 ohms. So it means our circuit diagram has become like this, and now we can go ahead and find the total resistance in the circuit, because the total resistance in the circuit means that we're having this effective resistance, the parallel combination, whose effective resistance is 3 over 2 ohms plus the 1 ohm. These two are in series, so we can go ahead and just add them up and get the total resistance in the circuit. So in this case, the total resistance in the circuit, that is to answer Roman 2, will be, total resistance is going to be R1 plus R2. We are going to add these two resistors since they are in series. So what is R1 is 1 ohm plus our R2 is 3/2 ohms. And so that answers the total resistance in the circuit now is 2.5 ohms, which is 5/2. So we have the effective resistance in the whole circuit. Roman 3 is to find the total current flowing in the circuit. From Ohm's law, we know that V is going to be equal to I times R. So to find the total current flowing through the circuit, we need to know the total voltage in the whole circuit. And according to our question here shows that the total voltage in the whole circuit is 2 volts. 2 volts so happens to be the EMF across the terminals of this cell. So this is the total voltage in the whole circuit. So this is going to be 12 volts is going to be equal to the total current in the whole circuit, which we are looking for. Multiply that by the effective resistance in the whole circuit. We got the effective resistance of the whole circuit to be 2.5, which is 5/2. So when we go ahead with our calculation, we make I the subject of the formula. We shall end up with current I giving you this is 2 volts. So this is 2 times 2/5. We shall end up with 4/5 amperes. Now in our last questions, we are required to find the current flowing through the 3 ohm resistor. Now again, from Ohm's law, we know that V is going to be equal to I times R. We want the current flowing through the 3 ohm resistor. Now this is the 3 ohm resistor. We can either pick on this one or that one. They just want current flowing through the 3 ohm resistor. Now the current flowing through the 3 ohm resistor means that we are supposed to deal with our resistance will be 3 ohms because we're dealing with a 3 ohm resistor, and our voltage should be the voltage that is across the 3 ohm resistor. Not the total voltage in the whole circuit, but the voltage across the 3 ohm resistor for us to be able to get the current. Now if I may take this back a bit, here in Roman 2 we were asked to find the total current flowing in the circuit. So for us to be able to find the total current flowing through the circuit, we considered the voltage in the whole circuit, the total voltage in the whole circuit, which so happened to be 2 volts, going to be equal to the current that we are looking for that is flowing in the whole circuit, which is the current that is coming from that dry cell. Multiply that by the resistance in the whole circuit. But now, here Roman 4, the final question, is telling us to find the current flowing through the 3 ohm resistor. So it means here we are only concerned with how much current is flowing through the 3 ohm resistor. So it means if we want to find the current flowing through the 3 ohm resistor, which is the I we are denoting here, we are going to be only concerned with the resistance of the 3 ohms times the voltage across the 3 ohms. Now the voltage across the 3 ohms is not the same as the voltage in the whole circuit, because the total voltage across this cell is going to be equal to the voltage across this 1 ohm resistor plus the voltage across this combination. That is in this diagram. Right here we are having 2 volts. This is the total voltage across the cell, and it is the voltage being distributed in the whole circuit. This 2 volt, the voltage in the whole circuit is equivalent to the voltage across there plus the voltage across right there. So it means that for us to find the voltage across the 3 ohm resistor, we need to know the voltage across this combination, because this 3 ohm resistor is part of this parallel combination. So our voltage there is going to be equal to the total current going through the circuit, because the current coming through this parallel combination, we got it before. It's going to be 404/5 amperes. Multiply that by the effective resistance across that combination. So to get that resistance, which is 3/2, we shall end up with, by 2 once, by 2 twice, which is 6/5. This is in volts. So it means that across this combination, our voltage is 6/5 volts right here. So if it is 6/5 volts across this combination, this simply means that the voltage across the 3 ohm resistor is 6/5 volts. So we have the voltage across the 6 ohm resistor. So we can continue with our working to get the current that is flowing through the 3 ohm resistor. So in this case, our voltage across the 3 ohm resistor, which so happens to be 6/5, is going to be equal to the current times the resistance, and in this case the resistance is 3. So it's going to become, our value of I is going to be 6/5 times a third. And when we make I the subject of the formula, we end up with 2/5 amperes. So the amount of current flowing through the 3 ohm resistor is 2/5 amperes, or call it 0.4 amperes. You could try that number and see if you get the answers. If you're unable to get the answer, just let me know in the comments below so that I'm able to post a video on how we get the answers. This brings us to the end of this video. Thanks for watching. Feel free to check out other excellent videos on the channel, and don't forget to subscribe. For Kisembo Academy, this is Arnold Rangakuramia helping you manifest excellence.